Yeah, my desk is a mess because I've been working on a pretty cool project. This project is a Raspberry Pi powered relay circuit that can turn lights or other household items on from anywhere in the world using, your smartphone or a tablet or a computer. It's all scratch built, and I even built the little controller board, and we're using the Raspberry Pi to power everything, and this will control up to 4 different devices, and all you have to do is plug them into this. And like I said, I plan on even building a little app for the phone. So anyway, I thought you would be interested in this. I plan to build this low cost. The most expensive thing in this whole project is a Raspberry Pi, which is $35. So anyway, if you're ready, let's get on with the build. It's a big one. Let's get started. Okay, so the plan real quick is we're going to be able to use a smartphone to turn on lights, appliances, sprinkler systems, or any device that plugs into AC mains. And the heart of the system is a Raspberry Pi, and if you don't know what that is, it's a little tiny computer that costs $35. That's our basis. We're going to build a controller that the Raspberry Pi connects to, and then that will have 4 different channels on it. And by using our phone or our computer or tablet, you can actually control these devices using that from anywhere in the world. And also you can set up schedules on your phone, or you can turn it on and off instantly. So that's the plan. Let's get started. I'm at my computer and I'm using Eagle to help me to design the circuit for the Raspberry Pi. And I thought I'd explain real quick how it works. See, the Raspberry Pi's GPIO pins cannot produce a lot of current, and it's very little, in fact, just enough to basically light a diode or two. That's about it. So we're using common components like this one here. This is an NPN transistor, and it takes the GPIO pin small current and amplifies it up slightly. And then we're sending that into this larger relay coil, and then that switches the power that allows us to use larger current devices such as household mains. And as far as these other components like this small diode, when the power is removed from the relay, EMF fields collapse, and this protects the circuit from destroying itself, basically. So it's pretty simple. If you want more information, there's plenty on the internet. Anyway, let's take this circuit and build a breadboard and see if we can get this to work. So what I've done is I've recreated my circuit onto this breadboard. Here's my little NPN transistor down here. Here's my relay, and then I set up a couple LEDs to let me know when the relay is open and closed. Right now it's closed, and the green would represent open. These 2 wires right here would go to the GPIO pin on the Raspberry Pi. This would be the ground, and then this would be one of the pins. I'm going to use this small alkaline battery to represent power coming from the GPIO pin. So let's go ahead and do that. So when I apply a small amount of power, you can see that it activates the relay and the green LED turns on. So that's it. It seems to work just fine. So what we need to do is reproduce this circuit on a board and multiply it by 4, because we're going to have 4 channels. So let's go ahead and get started on that. By the way, these relays came out of a UPS power system that I tore apart that wasn't working any longer. So I was able to get 4 of these out of it, and they're 12 volt. So they'll work just fine. So there it is, all together. Everything's soldered and checked. Let me show you some of the features. This is for 12 volt input here for DC to power everything, and I put an indicator light here so we know we have power. Down here, this is where the GPIO pins connect on the Raspberry Pi. You can see pin 1, 2, there's ground, which is common for all, 3 and 4. And I also marked the relays 1, 2, 3, and 4 so I know which one. On this side, these are the terminals for the actual relay connections, and this is what will connect the outlets to the board. So let's go ahead and try this out. We'll go ahead and use the battery trick again like we did before. Let's go ahead and power it up here. We'll just plug it in. You can see that the indicator light's working. And to test this, what I'm going to do is take the ground for the battery, put it in the center position, and then when I connect this to the other pins, the relays will click. Here you can hear that clicking. I've got my meter set on continuity, so I'm just going to put it in the first position here. And when I connect, it should, yep. Let's just go on down the line here. Number 2, number 3, and number 4. So good, it all checks out. The next step, we'll go ahead and hook it to the Pi. We've got some programming to do, and that's going to take a bit. And I want to write a little app for it so it can run on a phone or a tablet. And this is going to serve well. If I was going to do more than one of these, I would, make an actual board on my CNC machine and eliminate all this wiring. But this is good for a prototype, and I just may make more of these, I don't know yet, but nice little 4-channel relay that will work with the Pi. And also this will work with Arduino as well. The network for the resistors should be fine for the Arduino as well, but if not, it would be easy to change. Anyway, there it is. So I guess the next step is to try out with the Pi and connect it to the project and button it up. We're done. Hey, we're getting close. I've been working on this Raspberry Pi powered outlet box, and I'm at SolidWorks here, and this is what I've come up with. You can see it has ventilation, a fan at the top here, and then vent holes at the side. It's got mounting holes here at the base. You can screw it to a wall or a floor. And then it has 2 channels here that are independent. Then if I flip it over here, there's the other 2 here. Let's go ahead and slide this cover off, and you can see what's going on underneath here. So this square represents the homemade board that will be the controller itself. And then on this riser is the Raspberry Pi. Let's flip the cover up here so we can see what's going on here. You can see the outlets here. There's 4 channels and the fan. So I think that'll do well. This weird design for the cover, I was just messing around, seeing different designs that I could make and what the 3D printer would do, and I've been experimenting with the shapes of vents and stuff to prevent bridging, and we'll talk about that more in a minute. But anyway, let's go ahead and get printing some of these parts. Hey Shadow, what happened here? What happened? Were you hungry for a treat? Did you get yourself a treat? Did you get yourself a treat? Did you? You're guilty, aren't you? Now I gotta clean this mess up. Thanks. Okay, so this is my solution for mounting the Raspberry Pi. I came up with this tower looking thing, and this is going to sit above the other board. You'll see me glue this on later. But if you have one of these, what is this, Model B, you know that it's really awkward the way they made this. They put a screw hole here and here, and then they put all these parts, these connectors around the outside, and they're just in bad spots. It's just a bad design. I've never liked this. But anyway, what I came up with was this, and so I dropped my bolts down through, and I made these spacers that I'm going to put right there to keep it above, you know, a little bit above, and drop it in. That way this thing will get really good cooling. And I decided to go ahead and do this as a separate part so I could glue it in last, because what I plan to do, I can't get a hold of that little screw. What I plan to do is make this removable. This is the Wi-Fi antenna module, and I want it to stick outside the box. And rather than try to draw it in, I figured I would just make this removable, you know, until I get it glued in. And then I can just manually figure out how to make it poke out the outside of the box. So anyway, there's my Raspberry Pi mounted. We'll get that glued in here in a bit. wanted to show you what happened when I printed this lid. I don't know if you can see it, but this glass is actually bowed. This is a pretty flat surface, and look at that. So as this thing cooled, it actually bent the glass, and it cracked it too, right here. Look at there. Now that crack wasn't there until I let it cool down. Then it cracked, and it cracked here as well. So I'm going to have to go with a thicker piece of glass. I've been using the glass out of picture frames from the dollar store, and it's probably about a little less than an 1/8 inch thick, so I'm going to have to step it up to probably 1/4 inch. Now I haven't had problems until I started printing bigger things. This is quite a big print. Actually, it takes up almost the entire glass this way. And so I'm going to try some 1/4 inch. But yeah, look at that. And so what happened as a result, as you can see over here, it separated. Look at there. I'll be able to fix that, but I found that amazing that it actually bent that glass. And so what I'm going to go ahead and do is take this off there, and then I'll show you some of the features that I designed when I made this lid. Anyway, bent glass. You guys had any problems with that? I think a 1/4 inch thick would be better, but the heat transfer, isn't going to be as good. But yeah, I can't have that. Whoa. Look at that. Here's the cover that I just peeled off the glass, and it's not perfect, of course. I've got warping in here because of that glass, but it's still usable. But I wanted to show you some of the design elements that made this a little easier to print, and I'm learning as I'm using the printer different techniques that you can use. Now, with 3D printing and the way it works, you have to do bridging, and that's where you skip over a hole, and I'll show you in just a minute. But a way to make that possible is you use something called bridging, and you actually put support in there that you have to later cut out. And what it is if you have, let's just say this is a side panel. Let's say that it's this side panel here, and you wanted to put a square with no plastic in the center of that. What happens when you print that is, let's say my pen is the print head, okay? So it comes along and it starts depositing, goes across, layers it up like this. Now it's getting ready for the square, so it comes along, it skips, comes over here, skip. See, it's starting to make that square. Okay, now it's got the side panels. Now it's got to go from here all the way across to here. And what happens is there's no support right here. So what happens is the plastic sags down in that hole. And the way that you get rid of that is you actually print plastic here that you cut out later to support that up so that doesn't sag down like that. So a way to get away from that is to angle or round your holes. Now these are just naturally round because of the shape of the plug, so that's a plus, but let me demonstrate. So here's our new shape of what it looks like now, and it's rounded on the top and the bottom. So let's say my pen here is the print head again, comes across, deposits. So now it starts making this shape. A little bit longer. So what's happening is it's gradually building this rounded part here on the top and the bottom. So instead of having to when it's finished, it just go all the way across and would, droop down in here. It gradually, because of the way we've angled this, it gets a chance to be supported along the way. So you have a rounded shape here instead of a flatter shape. And the same is true with the vents that I made down here. I angled them so it eventually makes it a slot, but it just gradually builds it up so that you don't have any sharp edges, basically. I hope that makes sense. Anyway, let's go ahead and take this and start installing our parts, like our fan and our plugs. So one more thing I have to consider is about the fan. And if you mount it like this, you might be pushing air, and then if you turn it like this, you might be pulling. So I need to make sure that I mount this fan in there properly before I put it in. So I need to check it out. And generally, the fan will have a marking on the side with an arrow somewhere on here that shows you which way the air will travel and which way the fan blades will turn. Like on this fan right here. Now it's very small. I don't know if you can see it. But right by these wires, there's arrows that show you the direction. This one doesn't have it. So what I'm going to have to do is hook this up temporarily to just a battery to determine which way the air is traveling. So I'm going to put a couple wires here in my fan plug and just put it on a 9-volt battery with the proper polarity so I can determine that before I mount it. And on this particular project, I want the air to go into the case rather than pulling the air out. So let's feel this. So the air is going this way. I can feel much more air on my hand. So that's a way that you can test a fan. So now that I know, I can take my pen and just put an arrow like that. All right, let's get this mounted up and get my plugs in there. In there. So I decided to go ahead and just use these household type receptacles for my plugs for my project. These are going to fit in there nicely just like that. And this is a 4-channel controller. So each one of the plugs that I plan on using are going to be independent and controlled independently. The problem with doing that with this type of receptacle is these screws provide power for the terminals and pairs, and the reason for that is this is bridged right here. And to demonstrate what I mean, here's a ohms meter continuity tester. So if I were to go like this, you can see that these are connected. Now these are designed so that you can actually snip away this little bit of metal right here, this little bridge right in between there. And if you do that, then you'll get independent sides, and this will be independent from this just by using, the 4 screws. So let me go ahead and take my pliers and grab a hold of this metal tab and just break it off there. Okay. Now when I come in here and do this, you can see that it's not connected. This side still is, because I haven't broken this part off yet. Let's do that. So that's why those tabs are on there, so you can independently control these or add power to them. Now you can see that I'm independent, and these 2 screws will control this one, and these 2 screws will lead up to this one. So there's a little tip for you how to modify your receptacles. Well, I took good old super glue and I glued this tower that holds the Raspberry Pi onto the base. And then we have to wire it. So I think this is a good time to stop and make this part one of this video. And then the very next one, we'll wire it up, work on the software, and test it and finish it. And we'll have a nice project. This took me longer than I thought it would, so we're going to put it in 2 parts, so I apologize for that. Anyway, I hope you're enjoying this project and following along, and if you want to make your own, let me know and I'll make the schematics available on the website and you can grab them, including the plans to the case. I think it would be a nice switch for many things. You could switch up to 4 things anywhere in the world with a smartphone or a tablet or a computer over the internet. So yeah, it'll be interesting to see how it works out. So thanks for watching. Make sure you catch us next time and give us a thumbs up. We'll see you. Bye for now.